Good morning to all of my students. Myself, Mr. Dibyendu Mondal, Assistant Professor of Mechanical Engineering Department of Greater Kolkata College of Engineering and Management under JIS Group. In this pandemic situation, I am delivering my lecture through online mode and my video is uploaded in YouTube. Good morning, students. Today, I am discussing about minimum speed for starting a centrifugal pump. If the pressure rise in the impeller is more than or equal to manometric head, the centrifugal pump will start delivering water. Otherwise, the pump will not discharge any water through the impeller is rotating. When impeller is rotating, the water is contact with the impeller is also rotating. This is the case of a forced vortex. In case of forced vortex, the centrifugal head or head due to the pressure rise in the impeller. Omega square R2 square by 2g minus omega square R1 square by 2g. Omega R2 tangential velocity of the impeller at outlet and omega R1 tangential velocity of impeller at inlet. Due to pressure rise in impeller, u2 square by 2g minus u1 square by 2g. The flow of water will commence only if head due to pressure rise in impeller greater than equal to hm. So u2 square by 2g minus u1 square by 2g greater than equal to hm manometric head. For minimum speed, we must have u2 square by 2g minus u1 square by 2g that is equal to hm. Manometric efficiency that is equal to ghm by vw to u2. So, hm that is equal to manometric head vw to u2 by g. Now, substituting this value hm, u2 square by 2g minus u1 square by 2g that is equal to eta manometric into vw to u2 by g that is equal to u2 pi d2n by 60 u1 pi d1n by 60. Substituting the values of u2 and u1 in the equation 1 by 2g pi d2n by 60 whole square minus 1 by 2g pi d1n whole square by 60. তাহলে eta manometric equal to vw2 into pi d2n g into divided by g into 60. Dividing by pi n by g 60 we get তাহলে pi n d2 square by 120 minus pi n d1 square by 120. তাহলে eta manometric into vw2 into d2 pi n by 120 d2 square minus d1 square equal to eta manometric vw2 into d2. So n is equal to 120 into eta manometric into vw2 into d2 divided by pi d2 square minus d1 square. That gives the minimum starting speed of the centrifugal pump. The diameter of the impeller of a centrifugal pump at inlet and outlet are 30 centimeter and 60 centimeter respectively. Determine the minimum starting speed of the pump if it works against a head of 30 meter. Given dia of impeller at inlet d1 is equal to 30 centimeter 0.30 meter. Now d2 is equal to 60 centimeter 0.6 meter. Head is equal to 30 centimeter. Let the minimum starting speed equal to n. Using the equation for minimum speed u2 square by 2g minus u1 square by 2g, that is equal to hm. u2 that is equal to pi d2n by 60, pi into 0.6 into n by 60, 0.03141 n. u1 that is equal to pi d1 n by 60, pi into 0.3 into n by 60, 0.0157 n. So 1 by 2g 0.3141 n whole square minus 1 by 2g 0.0157 n whole square equal to 30. Now 0.03141 n square minus 0.0157 n whole square, 30 into 2 into g, 30 into 2 into 9.81. N square 30 into 2 into 9.81 divided by 0.03141 square minus 0.0157 square, 588.6 divided by 0.0009866 minus 0.0002465, 79527.6. n is equal to root over 79529.7.9, so 891.8 rpm. The diameter of an impeller of a centrifugal pump at inlet and outlet are 30 cm and 60 cm respectively. The velocity of flow at outlet 2 meter per second. Vanes are set back at an angle of 45 degree at the outlet. Determine the minimum starting speed of the pump if the manometric efficiency is 70%. So D1 is equal to 30 centimeter, 0.3 meter. Diameter at outlet D2 is equal to 60 centimeter, 0.60 meter. Velocity of flow at outlet Vf2 is equal to 2 meter per second. Vane angle at outlet phi is equal to 45 degree. Manometric efficiency, so that is equal to 70%, 0.7. So from the velocity diagram, tan phi that is equal to Vf2 by u2 minus Vw2. So u2 minus Vw2 that is equal to Vf2 by tan phi, that is equal to 20 by tan 45 degree, that is equal to 2. So Vw2 that is equal to u2 minus 2.0. So u2 is equal to pi d2n by 60. Pi is equal to pi into 0.60 n by 60. So that is equal to 0.3141 Newton. Vw2 that is equal to 0.03141 n minus 2.0. N is equal to 120 into n manometric, eta manometric into Vw2 into d2 by pi d2 square minus d1 square. 120 into 0.7, 0.03141 n minus 2 into 0.6. So divided by pi, 0.6 square minus 0.3 square. So 50.4, 0.3141 n minus 2 divided by pi, 0.36 minus 0.09. So 59.417, 0.03141 n minus 2.0. So 1.866 n minus 118.834 Newton. 1.866 Newton minus n, 118 minus 834. 0.886 Newton. So that is equal to 0.886 n. Okay. N is in RPM, 118.834. 1.866 n minus n. So 0.866 n, 886 n, n is equal to RPM. Okay. 118.834. So n is equal to 118.834 by 0.866, 113.22 RPM. A centrifugal pump with 1.2 meter diameter runs 200 RPM and pumps 1880 liter per second, the average lift being 6 meter. The angle which the vanes make at exit with the tangent to the impeller is 26 degree and the radial velocity of flow is 2.5 meter per second. Determine the manometric efficiency and the least speed to start pumping against a head of 6 meter. The inner diameter of the impeller being 0.6 meter. So first one, you have to draw the diagram. Here d2 is equal to 1.2 meter, diameter at outlet, speed is equal to 200 RPM. Efficiency, speed is equal to 200 RPM. Eta manometric GHM by U2, VW to U2. U2 is equal to pi d2n by 60. Pi into 1.2 into 200 by 60. So 12.56 meter per second. Tan phi is equal to Vf2 by U2 minus Vw2. U2 minus Vw2 is equal to Vf2 by tan phi. So that is equal to 22.5 over tan 26 degree, 5.13. So Vw2 is equal to U2 minus 5.13. 12.56 minus 5.13, 7.43 meter per second. Substituting these values in equation, we get eta manometric 9.81 into 6.07 over 7.43 into 12.56. So equal to 0.63, 63%. Least speed to start the pump. Least speed to start the pump is given u2 square by 2g minus u1 square by 2g, that is equal to hm, where u2 and u1 are the tangential velocities of the vane at the outlet and inlet respectively, corresponding to least speed of the pump. So u2 is equal to omega into r2, u1 is equal to omega into r1. So substituting these values in equation, we get omega into R2 square minus omega into R1 square over 2g, that is equal to Hm, that is equal to 6.0. Omega square by 2g, R2 square minus R1 square equal to 6. So omega square into divided by 2.981, 0.6 square minus 0.3 square equal to 6. So R2 is equal to D2 by 2, R1 is equal to D1 by 2, 0.6 by 2. Omega square, that is equal to 6 into 2 into 9.81 by 0.36 minus 0.09. So omega root over 436, 20.88, 2 pi n by 60. So n is equal to 600 into 20.88 divided by 2 pi. Now that is equal to 200 rpm. So multi-stage centrifugal pump. If a centrifugal pump consists of 2 or more impellers, the pump is called multi-stage centrifugal pump. The impeller may be mounted on the same more shaft of different shaft. A multi-stage pump is having the following important function: to produce a high head, to discharge a large quantity of liquid. If a high head is to be developed, the impellers are connected in series for discharging large quantities of liquid. The impeller pumps are connected in parallel. Multi-stage centrifugal pump for high speed. For developing a high speed, a pressure, a number of impellers are mounted in series or on the same shaft. The water from a suction pipe enters the first impeller at inlet and is discharged at outlet with increased pressure. The water with increased pressure from the outlet of the first impeller is taken to the inlet of the second impeller with the help of connecting pipe. At the outlet of the second impeller, the pressure of water will be more than the pressure of water at the outlet of the first impeller. Thus, if more impellers are mounted on the same shaft, the pressure at the outlet will be increased further. From suction pipe to delivery pipe shaft, number of impeller number 1, impeller number 2. That is the two-stage pump with impeller in series. Okay, two-stage centrifugal pump from suction pipe to delivery pipe. Now, N is equal to number of identical impeller mounted on the same shaft. Hm is equal to head developed by the each impeller. The total head developed N into Hm. The discharge passing through each impeller is same. Multi-stage centrifugal pump for a high discharge. For obtaining high discharge, the pump should be connected in parallel. Each of the pumps lift the water from a common pump and discharge water to a common pipe to which the delivery pipes, which each pump is connected. Each of the pump is working against the same head. That is, the two pumps are in parallel. Pump 1, pump 2. N is equal to number of identical pump arranged in parallel. Q is equal to discharge from one pump. So that is equal to N into Q, total discharge. That is the pump in parallel. Okay, common pipe and discharge Q1 plus Q2. Q is equal to N into Q. Okay, okay, thank you. Thank you. Last, if you like my video, you have to subscribe. Okay, thank you.